Yeah, let's start it. Okay. Yeah, so hi everyone. Very good morning and welcome to MuleSoft Mysore Meetup group. So today we have our speaker Shivani and we are going to explore Mule event processing models today. So before we start, let me let you know that this session will be recorded for your future reference, and you can find the recording through our Mysore Meetup group page or through our YouTube channel. And yeah, we let me introduce you all to the organizer of Mysore Meetup Group. So we have Shubham Chaurasia here. He's currently working with Millennium as a professional integration developer, and he's a MuleSoft mentor, speaker, and ambassador. And then we have Giridhar Mega. He's currently working as a senior technical architect with Ashton by Deloitte, and he's also a MuleSoft ambassador and mentor. And then myself, I'm currently working with LTM Mindtree as a senior software specialist, and I'm also a MuleSoft ambassador, mentor, and speaker. Okay, so please do reach out to us if you have any questions or if you want to provide any feedback or you want to become a speaker. Okay, we are there to help you out. So, yeah, I'll hand it over to Shivani to start with her introduction and then we can uh, move ahead with the agenda of today's topic. Yeah, Shivani.
Thanks, Priya. A very good morning, everyone. Let me present my screen. Is my screen visible?
Yes, yes. Can you just hide that pop up?
Yeah. Okay, so I'm Shivani. I'm working as a um, software development engineer with Ashton by Deloitte. And I have 4+ years of experience with MuleSoft integrations. And I'm also a MuleSoft mentor. And I have worked upon my MCIA, MCPA, and the MCD L1 and L2 certifications. So yeah, you can reach out to me over LinkedIn. Post the session anytime. Okay, so that's about me. So today we will be covering MuleSoft event processing models. So we'll be starting off with a little bit of introduction about the Mule 4 events and what are the event processing models in Mule 4 and the difference between blocking, non-blocking, parallel and reactive processing. And I'll give you a brief demo. There's a lot to explore on this topic. In the interest of time, we will cover the highlights and all the essentials that are required for us to move forward from here. And then we'll have a Q&A session to discuss any of your queries or doubts regarding the concepts that we have discussed. Okay, so we are good to proceed, right? I can get a reaction from you.
Yes, yes. We are good to start.
Yeah, okay. Thank you, Priya. Okay, um, so to start off with, Mule 4 is all event based, right? Mule 3 is a message processing model, and Mule 4 is more about Mule 4 events and event processing models, right? So, whenever you send a request to any of the Mule applications, so basically that request goes like a Mule event, and this is the structure of that Mule event, right? Any request that comes to Mule application is nothing but a Mule event, and that has the structure wherein there are attributes related to that request. If you are sending a body, then if you're sending a body with the request, then it will be a part of the payload, and any variables that get tagged along as the event is processed within the Mule flows, if they're variables and all, that will be stored in the variable section. So this is the general Mule 4 event structure, right? So keeping this event structure in mind, so we need to as especially when you are architecting Mule solutions, You need to keep in mind various processing models that you can make use of in your applications to process these Mule events as efficiently as possible. So, most of the real time applications today have a major challenge of scalability, right? So, you want to use the resources that you have as efficiently as possible, and you want the maximum resource utilization also, right? So so in order to ensure maximum resource utilization, and for your Mule application to not get blocked at any point in time, you need to make sure that you keep in mind the best Mule event processing models while you are developing your applications. So this is the brief introduction about what are Mule events. Since Mule 4 is all event based, at an architect level, it's very important and essential to keep in mind that scalability has to be achieved with great efficiency, and we have to make sure that resource utilization is proper. So we have to be conscious in using the best event processing models. Um, so any questions till now? I'll take a pause, um, or can we proceed?
We are good, Shivani.
Okay, so let's proceed. Okay, so um, as discussed, we have to make sure that the resource utilization is at its best, right? So Mule takes care, the Mule runtime completely takes care of the thread allocation of the application. Earlier, it could have been, it was possible through configurations, but when it comes to Mule 4, it is the runtime that takes care of handling, assigning the threads for the execution of a particular flow, and maintaining the proper resource usability. So, Mule 4 has come up with reactive event processing. So, it is supportive of non blocking processing. Basically, what happens in this processing model is, so you have a publisher and you have a subscriber. Okay, so these are also known as observable and observer. So your publisher is something that is observable, and your subscriber is something that is the observer, it is observing the publisher. Okay, so let us say your publisher is publishing or pushing the events to the subscriber, and the subscriber can consume those events. Now there will be a thread pool, right? And from that thread pool, your Mule runtime will pick the threads for the processing of these events that have been pushed by the publisher. Okay, now the size of the thread pool and how many threads are there, and all of this is basically decided by the infra of the system on which your Mule app is deployed, right? So it depends upon the number of cores that are present on the system in which your app is deployed. So differs from system to system. So let's take an example here. Let's assume that the thread pool has 10 threads. Okay, it has 10 threads. So now if the publisher is publishing, let's say, 5 events to the subscriber. Okay, so there will be a scheduler in between. Now that scheduler is also taken care of by the MuleSoft runtime. Okay, so that scheduler will pick up the threads from the thread pool, and it will make sure that the events that are published are consumed by the subscriber and they're processed. Once they're consumed, they're processed. So those threads allocated by the scheduler will make sure that the events are processed. So this looks like a fair scenario because we have sufficient threads available in our thread pool. We have 10 threads, and the publisher is publishing 5 threads. So, which is fine. Now, let us say that we have 10 threads in the thread pool and the publisher is publishing 10 events. Okay, so even in this scenario, it is still possible for the scheduler to allocate all the 10 threads that are present in the thread pool for the processing of these events. Okay, so all the threads from the thread pool, there is maximum utilization in this case. Okay, so all of them will be processed without any issue. Now, let us say the publisher is sending off some 200 events and we only have 10 threads in our thread pool. So, at this point, what the scheduler will do is it will allocate 10 threads for the 10 events, first 10 events coming from the publisher to get processed, and the remaining 190 events that are additional or that are an overhead on the number of threads that are present on our system, those will be rejected. The Mule runtime will reject those events. Now, this rejection is called as back pressure. Okay, so basically, all of this is again, it does not require your intervention in terms of building the logic. So as the architect, or with an architect and with a design mindset, we are trying to understand the role of Mule runtime in this reactive event processing. Okay, so that we can come up with the best models. So this is the basic non-blocking reactive event processing by Mule 4. So let's say we take a scenario, okay, of updating some files, okay, of updating some files at regular intervals. Okay, so we can sketch, I mean, if the number of files that are getting updated exceed the threads in the thread pool, or exceed I mean the maximum configuration or the vcore of our system, then the Mule 4 runtime will reject the processing of those excess files. Okay, this will apply to any Mule flow that you create in your application. Now the publisher, if we take a quick look at the Mule flow that I have created here, the publisher here is the listener. Okay, and in this case the logger is the immediate consumer of whatever events are coming from the listener. Okay, similarly you can have file systems also. You can have a file, I mean whenever a directory is getting updated or a new file is coming into the directory, you can listen to those changes. Okay, and based on the capacity of your system, the thread pool will have certain number of threads, and if your files, if the processing of the number of files increases the capacity of the thread pool, the excess files are rejected, and that's called back pressure. Okay, so this is the reactive event processing approach by Mule 4. Any questions till now? Are we clear?
No.
Okay. So whenever there is this back pressure, whenever the files are rejected, so those files need to be sent for processing again. Okay. So whatever 195, I mean, whatever 190 events were rejected, because we only have 10 threads in our thread pool. So those 190 events, I mean, if we want to reprocess them, we need to have a reprocessing strategy so that we can process them again. Okay. This
Like
will,
like the rate limiting, like
um, sorry, can you come again? I couldn't hear you clearly.
like a rate.
Can
It's
you repeat your question? I'm asking something.
it's like a rate limiting policy. It's like rate limiting. I
Okay,
mean,
is it
yes,
only with me?
it's
Yeah,
like
you
a
can
rate
even post
limiting.
your question on the chat window.
Okay. It's like a rate limiting policy. Rate limiting.
Gopal, actually, like your voice is not coming clear to us. If you can put your question to the chat.
Yeah. Hi, Shivani. Am I audible?
Yeah, hi, you are audible, yes.
Yes. You explained the scenario of back pressure, right? So, how to handle that scenario? Like, if you are pushing 200 files and some are getting missed because of that threshold values. So, how to handle these files? Like,
Yeah, so if you want to handle that scenario, you need to have a reprocessing strategy, right? So you need to have the trigger happen at regular intervals of time. Okay, so whatever events have been rejected, so they will go back to the publisher, right? So again, you need to have a reprocessing strategy to send those events to the subscriber again, or you can have a queuing mechanism in between where you can put those excess events in a queue and then send the events again when the subscriber is ready, or when the thread pools or when the threads in the thread pool are available. Okay, so you need to take a queuing mechanism, or you can go for reprocessing by making sure that the publisher sends those events at regular intervals of time until all of them are processed.
oh, got it. Thank you.
Okay.
Shivani, we have two more questions in the chat if you can.
Okay, yeah. Can I take those questions towards the end if that's okay?
Yeah, yeah, that's fine.
Yeah, I'll come back to all the questions at the end.
Yeah, Mahati, like you can by the time put your question to the chat. We
Yeah.
will check it.
Okay. Yeah, so till now we have discussed about how threads are getting used for processing the Mule events, right? So threads get allocated and then the processing happens. But what is the underlying architecture of how threads are, or how a Mule runtime selects these threads in the first place? Right? Until Mule 3, the threading architecture was different, but in Mule 4, there are three main thread pools, okay, which fall under CPU light, CPU intensive, and blocking IO category. Okay, all these three thread pools come under a main parent pool called the Uber thread pool. So if you see when you're deploying an application in your Anypoint Studio, you will see all of these words called Uber, Threadpool, Grizzly. So all of these words keep coming when the application is deployed. Okay, so we'll try to make some sense out of what these mean and how the Mule runtime underlying takes decisions of what thread pool, of what kind of thread to use for what kind of event processing. Okay, so now CPU light threads are used for the Mule events that take less than 10 milliseconds of processing. Okay, so these are 100% non-blocking tasks, they quickly get executed. Some examples are like, your logger, right? The execution of logger is quick. Then your set variable, right? These are all small modules in your Mule application that do not take a long time to get executed. um, your set payload, right? So all of these are very simple, and they take the threads from the CPU light thread pool. So whenever the Mule runtime comes across a component like this in your Mule flow, then it picks up a thread from the CPU light thread pool, and it processes that Mule event. Now, let's say your Mule application is having some components that take longer processing time. Let's say you have written a really big um, transform message, data weave script. Okay, so in one of the projects that I have worked on, we had a very huge 4,000 lines JSON incoming message, and that message had to be formatted into different sections. So basically that message had arrays, it has nested arrays, it had object in objects. So it was a complicated JSON message that we were receiving. We had to properly divide it into different sections, and then we had to create a PDF out of that 4,000 lines of JSON input data that we were getting. So this was a very tedious scripting work that had to be done in the transform message component, right? So it will definitely take more than 10 milliseconds, or it blocks at least 20% of your clock time. So for executing such Mule events, the Mule runtime will not pick a thread from the CPU light thread pool. Instead, it will pick from the CPU intensive thread pool. It will pick a thread from this pool, and it will make sure that the execution of that Mule event happens. Next thread pool is the blocking tasks. Okay, so these are the tasks for which the thread will wait till the completion of that particular operation. Like for example, there is a transaction in your Mule flow. You have like a couple of event processors that form a block of transaction. So in that case, you cannot, your Mule runtime will not assign different threads to the different processors in the transaction block. Okay, it will use one thread, it will block one thread till all of those processors have successfully completed or failed. Okay, so example of the blocking IO can be when you are making a database call from your Mule application, when you are inserting or selecting an operation, so inserting or selecting a record into your database. So all of these operations, for all of these operations, your Mule runtime will pick a thread from the blocking IO thread pool. Okay, and it will use that single thread until that insert operation on that database is completed. Okay, just like how one thread was used for completing the insert operation of the database, similarly a transaction consisting of several processors will also utilize one thread to complete the processing of the entire block. Okay, so these are the three different thread pools that the Mule runtime keeps switching, and this is auto tuning, basically done by the Mule runtime. Okay, there is no manual intervention that a developer needs to do in order to pick these threads from the thread pool while executing their flow. Okay, so we'll just take a quick look at this flow. So now for example, I have a listener and I have a logger here. So as a developer, I don't need to think about which thread will be picked when the Mule event flows from listener to the logger. The Mule runtime will take care of that. Okay, right now I don't have the logs. I will deploy it and I will show you. Okay, one second, I have it here. Yeah, so you can take a quick look. So you can see something called CPU light mentioned here, right? So a CPU light thread has been picked up by the Mule runtime to process the event from the listener to the logger, because logger doesn't take long time to process. It's a simple thing, right? So it will only take a CPU light thread. Now if I have database operations, if I have complex scripting, then instead of CPU light it will go for a CPU intensive thread. Okay, so let's take a scenario of how thread switching happens in MuleSoft, right? So again, this is all auto tuned. We don't have to take care. We are just understanding how Mule runtime takes care of this. So this is basically a flow. You have a listener, you have a database select component, then you have a logger, then you have a data weave component, a scripting component, and then you again have a logger, and then you have a listener. Okay, now the thread pools that the Mule runtime deals with is a CPU light thread pool that we have already discussed, that it's used for the events that take less than 10 milliseconds, and then there is a CPU intensive thread pool. Okay, and this is like 20% of blocking time, or which takes more than 10 milliseconds to get executed, the components that take more than 10 milliseconds to get executed. We use CPU intensive threads for that. And blocking IO, and there is something called shared grizzly and dedicated grizzly. So shared grizzly and dedicated grizzly are used by HTTP module. Okay, so if it is a HTTP listener, it makes use of a shared grizzly. Okay, so if it is a HTTP requester, it makes use of a dedicated grizzly. So there is one shared Grizzly thread pool for a runtime, and all the applications that are deployed in that runtime will make use of this shared Grizzly. So all the HTTP listener components that are deployed on that runtime will make use of the shared Grizzly. Okay, so these are the different thread pools now that we know. Now how does the Mule runtime does the thread switching as the Mule event progresses through this flow? So first we have the Mule event, which could be a request, right? Which a request coming from any of the client applications to the Mule application. So in that case, you can see in the shared Grizzly there are many threads. So one of the threads, thread number 10, is being picked up. Okay, and from here we are moving the thread to the database select. Okay, regardless of what component is present after the listener, a CPU light thread is always used to pass a Mule event from the HTTP listener to the next connector. Okay, so a CPU light thread is used for doing that. Now we know that a database operation is an IO operation. Okay, so one thread will wait till the completion of that database select operation. So a thread from the blocking IO thread pool has been picked up to complete the database select operation. Now once this is complete, we have a logger, right? So for executing the logger, again a thread from the CPU light thread pool has been picked up. Now we have a data weave component, which is doing some transformation on whatever database records have been selected. So that data weave component will definitely take some time, more than 10 milliseconds, for the script to execute. So the Mule runtime will this time take the thread from CPU intensive thread pool, and it will do the processing. Now, once this is done, we have logger and HTTP requester. So the Mule CPU light thread will take care of the processing here. And now the requester has to return the response, right? Whatever response it has got, it has to send that back, right? So for that it will use a dedicated grizzly thread. Okay, so this is how, this is a single flow. What you see from the left HTTP listener to the HTTP requester, it's a single flow. And these are the various thread pools that are present in the Mule runtime. And this is a scenario that we have seen about how a Mule runtime performs thread switching. Okay, this is all done internally. We should be aware of how the Mule runtime is doing it. And this is how auto tuning, this is also called auto tuning or thread switching. So picking up different threads, releasing different threads. So basically once your data wave operation is complete, the thread number 16 which was picked from CPU intensive thread pool gets released back into the thread pool. So now it's available for something else to pick it up, right? So this way maximum resource utilization is ensured. Okay, and scalability is achieved properly. Okay, so yeah, so this is a scenario that will help us understand how Mule runtime achieves thread switching. So any doubts with respect to the scenario?
We have not got questions yet, but yeah, we have two questions which was asked earlier. If you want to take it up.
Yeah. uh, One second. Okay, so one of the questions is each and every component communicating. Um, yeah, Gavaskar. So, correct. Each and every event based model means that each and every component is event based. Yes, that is why every component in MuleSoft in Mule 4 is called an event processor, right? So the example that I was showing you in Anypoint Studio, the logger is an event processor, the transfer message component is an event processor. So a workflow is like a tunnel, is like a channel, right? So in that channel, these all are event set of event processors, and they are processing nothing but an event that is coming to them. Like let's say I send a request to my application, that request is an event, and all these event processors that form the workflow are processing it, right? So that is called event. That's what is the meaning underlying event based model. Now coming to Sadnek's question, what is the significance of the term reactive? So basically reactive means you are behaving as per the resources that are available to you. Okay, so in case of the scenario that we took, we had 10 threads in the thread pool, right? So what we were doing was, if the number of events that were coming were more than 10, right? So we were sending them back or we were rejecting them. Okay, and we were processing only the ones that we could. So this is called reactive processing. You are not letting your system crash abruptly, or you're not letting your system block because of those excess events that are entering your application. Instead, you are reacting to those excess events, and you are saying that I will not process, I will reject these events, you send me these events for reprocessing. I will only process the events that my thread pool supports. So that's the significance of the term reactive. When your application or when your runtime is capable of processing based on the resources that are available and rejecting the excess requests that are coming in without crashing or without blocking the application. Okay. So can we proceed?
Yes, sure.
The how to reprocess rejected events. So like I mentioned already, we can make use of queuing, or we can add schedulers, so that the publisher keeps sending the events that are not processed at regular intervals until all of them are processed.
Hi, this is Reni.
Yeah,
Am I audible?
yeah, Srini, you are audible.
Yeah. So as you mentioned, we have to use queuing, right? So which
Mhm.
means after the listener, we need to use some queuing mechanism, right? That's what you are
Mhm.
mentioning, like
Mhm.
any MQ or VMQs.
Mhm. Mhm.
Let's say I have a flow where I have two listeners. Okay.
Okay.
Uh, if one flow is receiving
Okay.
access. Okay, already 10 sets are there, 200 messages are receiving.
Okay.
Uh, in this case, it will reject there only, right?
Yeah,
So
it will
there's no
reject. Yes.
other flow. I don't have any queuing. One flow I have queuing. So
Okay.
obviously it will go. It will. I can reprocess, but we cannot. The other flow we don't have any such uh, mechanism. In this case, listener itself it will reject.
Yes. Mm.
We cannot. So obviously we lost the data, right?
Yes. Yes. If you do not have a reprocessing mechanism, then yeah, they those that information is rejected. Yes, it is not processed.
Okay. Is there any, let's say I have a single worker and then the size of the vehicle is 0.1. Is there any, that pool size is default, that pool is there mentioned? I mean, MuleSoft is giving like 10, you mentioned 10. Um, is there any default that pool size?
There is no default size as such, Srinivasulu. Probably I'm not aware of that exact number that you're asking for, but it depends upon vCore to vCore. So usually in some local systems there are, four cores present. So we cannot tell how. It depends upon actually different calculations. So if you have, let's say, four cores on your system, then maximum of the number of cores, twice the number of cores threads can be utilized. So those many events can be sent. So there is no default number as such, but let's say you have zero point 0.1 cores, then twice that number is the maximum number of threads that it can handle, and those many events can be sent. So now, whether it can handle two listeners that are getting maximum events or not, that we have to check.
Also, it can be affected by the number of dedicated Grizzly thread pools. In other words, the number of outbound requesters. So if you have a process layer with a greater than one number of outbound HTTP requesters, that can reduce the number of available threads for the Uber pool.
Francis, can you come again with your question?
Well, it's not a question. I was just saying that the number of threads available in the Uber pool would be reduced if there are a large number of outbound HTTP requesters.
Yes, yes. Basically, it depends upon the processing time of that requesters also. See what source system a particular requester is requesting. So if the target system is returning a response quickly, then the thread will be freed easily and it will go back to the dedicated thread pool, right? And then it can be utilized by another requester. So one of the point that you mentioned is correct. Like if there are more number of requesters, more threads from the dedicated thread pool will be utilized. And also it depends upon the fact that how long is the target system taking to respond. If it is responding quickly, then even though there are more number of requesters using the dedicated thread pool, they will be freed up easily. Okay. If it is taking longer, the target is taking longer, then the thread is occupied for a longer time. Yeah, yeah, but what you said is correct. Yes.
Thanks, Francis.
Okay, so let's proceed. So this is one of the scenarios that we looked into uh, for thread switching. Now, let's take a look at another scenario, which is a transactional scenario. So, in this case, I have a listener in my flow, and there is a try scope. And within, so basically, this try scope is transactional, which means I'm expecting, the expectation is that the database component, the select, the logger, the data weave component, and the database insert component, and the HTTP requester execute as a transaction. They either succeed or fail together. So in that case, how does the Mule runtime does the thread switching? So first, the HTTP listener is taking a thread from the shared Grizzly. Okay, the event goes from there to the database select using a CPU light thread, and from there, since it's a complete transaction, we are picking a thread from the blocking thread pool, and we are completely using that one thread until the execution of this transaction is either successful or failed. So once it is complete, then the requester is using a thread from the dedicated Grizzly to return the response. So this is how thread switching is happening in transaction. The concept is same. Okay, how we discussed thread switching, the logic behind selecting the threads and how Mule runtime does is the same. It's just that if it's a transactional block, in that case, a Mule runtime will not assign multiple threads, CPU light, CPU intensive. It will not switch between multiple threads. It will use a single blocking IO thread from the blocking IO thread pool, and it will use that till the completion of that transaction. Okay, so that is about thread switching. Now moving forward, we have Mule flow processing strategies, right? So we have the first processing strategy is the sequential processing, right? Where you have like, let's say, so this is an example of like sequential processing, where first the logger is coming into play, then I am using a connector that is requesting a REST service to get some flight details. Okay, so then I'm using a transform message. So the Mule event is going from one event processor to another event processor in a sequential manner. So this is nothing but sequential processing. Okay, so when the input of the previous event processor is important for the next processor is, or the next processor is dependent upon how the previous processor behaves, then you go for a simple sequential processing model, right? This is a sequential flow. Now you can also go for parallel processing. Okay, so for parallel processing, we have multiple options in MuleSoft. We can go for a parallel for each, or we can also go for a scatter gather component. So we have scatter gather component. This also lets you parallelly process the event. So in case of scatter gather, let's say you have an event coming from the source system, you can make sure that you are scattering it to various routes. Okay, and those will be processed parallelly. So let's say if there is an event, and I want to send those event to multiple requesters, so I can do it parallelly. You can have multiple routes like this. So this is one way of taking care of parallel routing. So in parallel processing, what we need to understand is these routes are not dependent on each other. The three routes that you see here, they are not dependent on each other. However, they are only dependent on what comes from the source. Okay, so when the dependency is like that, you can make use of parallel processing. And not only scatter gather, you also have batch processing in case you are dealing with heavy amount of data that you are transferring from your source to the target system. So in that case, you have batch processing also, which um, takes a set of records and then parallelly processes them. Okay, which means that the processing of one record is not, I mean, let's say there are 10 steps, 10 batch steps, and you have one record. So the system will not wait for that one record to complete all the 10 steps. Once the first record completes the first batch step, it goes to the second one, and the second record will go to the first batch step. So we are not waiting for one record to complete all 10 steps, right? So parallelly, the second one has already started its first step. So this is another example of parallel processing in MuleSoft. So when you know that your um, different tasks are not dependent on each other and they are only dependent on one common thing or one common source, you can go for parallel processing. Okay, this will save a lot of time for you, and you will get the result faster than sequential processing. Okay, so that's about parallel processing. This is another flow processing strategy. And then you have asynchronous processing. Okay, so asynchronous processing is like you are not expecting a response, right? You are sending a request and then you don't expect a response in return. So for implementing asynchronous processing, you have your endpoint MQ, where you put your MQ has all the events queued up, and the subscriber to that queue will listen to those events and process at their own time. So it's always good to use queues it's important to make sure that you have reliability patterns in place when you are asynchronously communicating, because it is possible that you can lose data, and you can lose some important messages while asynchronous processing. So make sure that you use proper MQs, proper queuing strategy whenever you are going with asynchronous processing, so that at the end of the day all the messages are processed. Okay, so these are different flow processing strategies of how you can design your flows. So I showed you an example of sequential flow. I showed you that we can use scatter, gather, batch processing for parallel flow, and for asynchronous flow processing, we can use the queues, right? We can use publisher, consumer, and all of these. We can use queues. Um, Now coming to Mule event processing strategies. So the first strategy is the most straightforward one, a simple strategy where you have a source system and a target system. There is a request from the source to target, and the source is expecting a response, so the target will return a response. So this should happen in a very fixed time interval, because the source cannot wait endlessly for the target to return a response. So we have to make sure that the target system does not take long time to return a response. So in one of my projects, we had a requirement to create an account, right? So the user was entering the all the account. He was basically onboarding. It was a banking application, and he was onboarding. And we were talking with a third party system to create an account for that person, and we were expected to return the response within 3 minutes. Okay, so we could not, the application, the Mule application was expected to return a response within 3 minutes. So we had to design all our components and flows in a way that whatever processing is required in between for creating an account at the backend, we take care in such a way that the process is completed within 3 minutes and the target is giving some response to the source. So this should happen in a fixed time interval. Now, next is synchronous idempotent, right? Now, let's say you have a situation where your source and target are communicating synchronously, but somehow your source system is down. Okay, so your source is not able to receive the response that the target has given, because it has crashed, or it is facing some downtime. So it is not able to receive the response from the target. So in that case, what if the source sends the same request to the target again? It's a duplication of that request, right? So we have to ensure that the target is not accepting such duplicate requests. The rejecting that duplicated request is only called as idempotency. So in MuleSoft, we have something called idempotent message validator. Okay, so this component ensures that only unique messages are received by the service. So you can make sure that with every request that the source is sending to the target, there is a transaction ID associated, and the next time the source sends the request with the same transaction ID, the target validates that transaction ID and rejects it, saying that this request has already been processed. Okay, so if you have that component like idempotency component that MuleSoft offers, you can prevent the processing of duplicate requests, even if the source system is down and not accepting the responses from the targeting time. So this is one more event processing strategy that you can implement in MuleSoft using the idempotency validator component. Next, you have something called content negotiation. Okay, so there will be scenarios where your source system will expect the response from the target system in a particular content type. Usually when we create raml specifications, we define the acceptable response format at the source. Let's say it's application JSON or it's application XML. Then we have to make sure that the target system is returning the acceptable content type to the source. Usually the content type that is accepted is always sent in the header section of the Mule event. So here I showed you the Mule event, right? So Mule events headers will be present in this attribute section, and in this section you can specify the content type that is acceptable by the source. So in case your Mule system is returning some response to the source, you need to make sure that you are using a choice router. You are appropriately checking the content type that is accepted by the source. And let's say your flow is not returning a content type accepted by the source, then you have to use a transform message component. Okay, let's say the source is accepting XML and your flow is giving JSON. Then you have to convert the JSON to XML and you have to return it to the source system. So these kind of content negotiation strategies can also be taken care of with Mule system, and this is also a synchronous communication. Now next is synchronous quick acknowledgement scenario. Okay, so what the simple use case of this scenario is when you place an order on Amazon, right? So usually your order is not delivered. So the transaction is complete when you place an order from Amazon and the order is delivered to your home. That's when it's like a complete successful transaction. But in real time, you are placing an order and the backend has to do multiple tasks like searching their inventory whether the product is there or not, and then shipping that product, and then sending it to your city, and then finally getting a delivery agent to send that product to your home. So these are multiple tasks, and you as a customer cannot wait for this whole thing to happen until you get a response from the application, right? So that is why what do you get usually? You place an order on Amazon, you get a order ID or you get a transaction ID with your details, right? And over the time, you keep tracking your order. So after 1 or 2 days, you will track where your order is. Okay, although the transaction is not complete, there is a quick acknowledgement that is done to you by the application, right? In order to do that, when the source, let's say a client application is sending a request to Amazon, Amazon will perform some validations just to see the validity of the, I mean, how valid the order is, can the order be processed or not. They will do the basic validations and they will give you a response, right? Let's say you have ordered a mobile phone. So they will see whether that mobile phone is present or not, available for selling or not, and they will give you that details, price details, order ID details. That's a quick response that you will receive within few minutes once your order is confirmed. Now using that, then the processing is not complete there from the application side. They will process it to their JMS. They will publish it to their queues, and then JMS listens to that event. Then multiple tasks are performed, like shipping that phone, packaging that phone, and then delivering it to your location. Now that again completes your transaction, and you get a final response saying that the order has delivered. Okay, so there are two phases here. One is the quick acknowledgement that you get from the application, and at the back end the application takes care of multiple tasks, and you either get an order ID to track the back end tasks, or you get a callback URL, right? The same happens when you are applying for a job, right? So you make an application, you send you send an application to a particular job, and they give you a callback URL saying that you go to this URL, which is your candidate home, and you can keep a track of your application there onwards, and from there you keep track of multiple tasks like interviews or whatever. Okay, so this is called synchronous quick acknowledgement event processing pattern. So any questions till now? So we have discussed four Mule event processing strategies. The first one is the simple synchronous event processing strategy. Then we have discussed idempotent event processing strategy, content negotiation, and quick acknowledgement. Any questions so far? Okay.
Yeah, we are good.
Okay. All right. So I see it's already 11:32. So I'll quickly cover the rest of the content. We are almost done, and then we can take up Q&A. Okay. Yeah. So then we have Mule event processing strategy, that is asynchronous. So this is nothing but the pub sub pattern, where the source is the publisher and the target is the subscriber. So source is publishing the events to the queue, and the target will listen to the events that come to the queue, pick it up from the queue, and process the events. So this is the publish subscribe thing. So the publish subscribe architecture. So usually when, let's say, there is a source system, and let's say I'm a school, I'm running an educational institution. Okay, so let's say I want to send out some assignments or some data for the target to process. So I will have those events placed in a queue, and the target, when it is available, it will pick up those details from the queue, and it will process at its own pace. The subscriber will process at its own pace, right? So we get emails, right, where we subscribe to a particular channel, we subscribe to a particular magazine, or any such similar scenario where they publish data, and we subscribe to them and we process that data, right? Next is asynchronous JMS topic processing strategy. So this scenario is when a single source has to give to multiple hospitals, multiple targets. So I just had the hospital scenario running in my head. So you can have a diagnostic center, or you can have any data collection lab that is collecting the reports of patients, right? Let's say the patient want to get a COVID test, they will go to a diagnostic center and they will get those tests done. And let's say that diagnostic center want to send the COVID positive cases to multiple hospitals. So each hospital will have a queue of their own, right? So likewise, you can, first of all, the source will send the information to a topic, and depending upon what information a particular hospital wants, you can apply required filters, and only that data will be sent to the respective institutions queue. So when your requirement is like this, where a source has to send the data to multiple target systems and each target required filtered data, so you can make use of GMS topic. Then you have JMS message acknowledgement system. So here you have a queue. Okay, your JMS listener is listening to the queue. So there can be different sort of acknowledgements that it can give. So if it's an immediate acknowledgement, as soon as the listener is picking up an event from the queue, it will give an immediate response saying that okay, I have received this message, I've picked it up. If it is an auto, if this acknowledgement mode is set to auto, then it will wait for all of these tasks that are present, task 1, task 2, and only then once it is complete, then it will give an acknowledgement. If it is a manual, if you set the acknowledgement to manual, then you can see that you have an acknowledgement component at the end of the flow. Okay, so after the two tasks are complete, a manual acknowledgement is sent. Okay, now there is other acknowledgement method also, which is called duplicates. Okay, which means even the duplicates can be processed by that listener. Okay, so these are the various asynchronous processing strategies that you can incorporate based on the use case that you are provided with. Okay, so yeah, so all in all, in today's session, if I give, let me give you a quick summary. So we have covered what is non-blocking or reactive event processing by Mule 4. Okay, and somebody asked me on the chat, how does Mule reject it? So how does Mule reject it is taken care of by the Mule runtime, right? Whatever excess events are there, the Mule validates it against a number, right? So let's say your system is having 4 cores and it can accept 4 events. So that is configured in your scheduling dot scheduler. If you open your Anypoint Studios config files, that is where your vcores will be there. I mean, how many vcores that are allocated to the particular system will be present. So the incoming events will be validated against that. And if the incoming events are exceeding the number that the application or the Mule runtime can handle, the Mule runtime will reject those, which means it will not process those, and that itself is called back pressure. Okay, so the rejection is based on what amount your system can process, and that processing is present in your Anypoint Studios configuration files. Then we discussed about thread pools. We have 3 main thread pools, and we have discussed which thread pool is used in which scenario. We have discussed a thread switching scenario in a non-transactional way, and also we have discussed thread switching in transactional scenario. We have discussed flow processing strategies, sequential, parallel, and asynchronous. And then we have discussed event processing strategies, synchronous ones, idempotent, content negotiation, quick acknowledgement. And then we have discussed asynchronous mule event processing strategies. So this is what we have covered in today's session. Any questions so far? We can spend some time with questions. I can see it's already 11:40. We're 10 minutes past our session timing. So there is a quick demo. I have already executed that demo. All right. So I just wanted to show you that this is how I had a flow. Okay. And how this flow used a CPU light thread, how the Mule runtime has selected that CPU light thread to process this entire flow. Okay, so that's the quick demo I wanted to give you. In the interest of time, I have already executed and kept it. Yeah. So there's a lot more to be discussed about Mule event processing models, as to how we can use this idempotent message validator. So for every scenario that we have discussed here, we can have demonstration or a scenario built or a mule flow built. Yeah. So yeah, we can explore it at our own pace, and we can regroup and discuss whenever we can. So yeah, that's all from my side from the content perspective. Now we can take up the questions.
Yes. So if you have any question, feel free to unmute yourself and ask. We will just take 2 minutes, yeah, for the questions.
Hi, Shivani. This
Hi.
is Mahati.
Hi, Mahati.
Yeah. So I have a scenario where I have to pick up the files from SFTP,
Okay.
but I have like more than 20, 30 files have been placed in SFTP, but our Mule integration is picking up files at the rate of 5 or sometimes 4 files at a run. Like it is scheduled to run every 15 minutes and it's picking up.
Mm-hmm.
So we try to change the thread pool size also. Like in the SFTP listener, we have we can set right. So we are using that pool size, even though we set it to maximum, but it is
Mm-hmm.
only processing 5 files max at a time. Is there any way like we can increase the pool size, or we can collect more number of files from the in one schedule? Is there any way like
So actually, yeah. So Mahati, like you said, you have already configured it to the maximum. So number of files that can be processed will always be depending upon the processing capacity of your system on which the application is running, right? So if you're already using the maximum capacity and the maximum threads that are present in the thread pool, then the only option you have to accept more files is to go for horizontal scaling. So you have to horizontally scale your infrastructure in order to accept more files, because you're saying that as a part of vertical scaling, I mean, you are already at the 100% utilization, where your app is running on a system and utilizing the 100% resources of that system. You have set it to max, right? So that's what it can process. Rest all it will reject, and if you further want to process more files, there will be delay, because you have to do reprocessing. You have to apply reprocessing strategy. If it is only taking 5 at a time, then whatever extra files are coming, until those 5 are processed, you cannot send further. Okay. Once that complete the 5 files are processed, if you don't want to horizontally scale, you have to wait till the threads that are available that can process, and once they are free, they can pick up again the files and they can reprocess the rest of them.
okay? So it's like even my only understanding is even though I kept it at the thread pool size of 5, it is picking 5 files. Then I updated thread pool size to 8. Then also it is picking up 5 files only. That's
Yeah,
what I'm saying. So,
yeah, it is depending upon how much your system can handle, right?
okay.
Your system can only handle what is allocated to it, or what is present, what is present. Like say your laptop itself is having some 4 cores, and you assign even 8 cores, so it doesn't have that capacity to execute, right? So even if you are in the application configuring it to more, the underlying infra is only limited. So according to
Understood.
that, it is getting processed. Yeah.
So it's just not based on the thread pool. It's also based on the cores that we are using to process the
Yeah,
file.
yeah, the thread pool assignment happens based on the underlying core only. The maximum thread pool, let's say you have 4 cores, maximum CPU light threads can be two into the cores, twice the
Understood.
cores.
Understood. Yeah, thank you.
Yeah, thanks.
Yeah, do we have any more questions? And for your information, like you'll be getting one feedback survey link on your email after this session. So we like do share your feedback to us. And if you have any more questions, or if you want to become a speaker and want to give feedback for a topic which you want to hear in our next session, yeah, do reach out to us and let us know. We will be like, you can reach out to us through our Mysore group meetup page. You can inquiry from that page, or you can also reach out to us over LinkedIn. Yeah. And yeah, we do have a WhatsApp group page, WhatsApp group in our for our Mysore group. So yeah, you can join this link and you can get the latest update whenever a new session will happen. Yeah, if you do not have any question, then we will just close the session in 1 minute.